Good day, ladies and gentlemen. Today we are going to speak about important theorems that comes from parallel lines, and there we are referring to things like what? We are referring to things like corresponding angles, co-interior angles, and alternate angles. So today we are going to look deeply into what these theorems are and then how to use them. And ladies and gentlemen, personalities, it is very important to understand these basic theorems, because in mathematics it's not usually the difficult things that causes problems. It's usually those simple things like this one. So if you are doing grade 8 to grade 8 and grade 9, this will be directly examinable. They will ask it directly. And then if you're doing grade 10, there's a little bit of asking directly as well. But when you are doing grade 11 and 12, there will be questions that will be looking for this kind of information. So each and every person who is listening here, who is in high school, can be able to benefit from these theorems. Okay, so now how do we look at these kinds of theorems? Okay, now when they say, let's start with corresponding. When they say corresponding angles, what do they mean? So basically what will happen is that you will have a line like this one, okay, right? And then you will have transversal line. Don't be scared by a big English word, transversal. Transversal simply means that you've got two lines that are cutting one lines. So for example, in this particular case, you will have a line cutting this line here, and then you've got a line cutting this line here. That is true to transversal lines. But now these two lines are not just lines, they are parallel lines. So this line is parallel to this line. So if you have a line like that, a line parallel to another line, then they say that if you have corresponding angles that are found in between those lines, corresponding angles. Now they say those corresponding angles are going to be equal. Now when they say corresponding angles, it's a big English word. What does it actually mean? Ladies and gentlemen, personalities, corresponding angles simply mean that one of the angle is here and then another one is here. So this angle corresponds to this angle. So if you have angles that are standing in a line that is F-shaped, and then that F is formed by parallel lines, then those angles are what? Are corresponding. So this angle is corresponding to this one. Now this theorem is saying what? It's saying that corresponding angles, I'm going to say for corresponding angles are equal. So we are simply saying that if you've got 30 degrees here, that means here as well is 30 degrees. If you have 40 degrees here, it means here you also have 40 degrees, because they are standing in a certain way that we describe as what? As corresponding, and then they are parallel lines. Okay, so if you have parallel lines, that's what the theorem says, that if you have parallel lines, okay, and then those two parallel lines are cutting a line, then the corresponding angles that are going to be formed there, they are equal. All right, now there is a second one. You've got parallel lines again. So you've got this line being parallel to this line, and then there is a line here. Now these two lines are also transversal lines, but they're not just transversal only, they are parallel. Now, geometry says that if you've got these kinds of lines parallel to each other and then cutting this one line at different points, therefore these angles, if you add this angle and this angle, you must get what? You must get 180 degrees. So 180 degrees, there is a nice English word for it, which is supplementary. So you are saying you say co-interior angles are what? Are sup. Okay, so what does supplementary means? It means when you add, it give you what? 180 degrees. Okay, and then there's a third thing that is being said about transversal lines again. If you've got transversal lines which are parallel, therefore the alternate angles are what? Are equal. So if these lines are parallel, then this one is equal to this line. So if we shorten it up, we'll say all alternate angles equal. All right. Now, if you can look, because I know as learners, we always try to find a way in which we can remind ourselves about these kinds of things. So this one is F, this one is U, this one is N. Okay, so it's fun. All right, so now here is this theorem. Let me just write it down. If you have parallel transversal lines, okay, if you've got parallel transversal lines, there are three things that you can say. Then, now what is the first thing? Number one, corresponding angles are equal. This is what you are saying, eh? And then number two, co-interior angles are supplementary, which means 180 degrees. And then lastly, you can say that alternate angles are what? Alternate angles are equal as well. All right. So, ladies and gentlemen, personalities, what am I saying to you? Mr. Makaba, what are you saying to us? I'm saying something simple. I'm saying that if you see parallel lines in your geometry, without thinking, you must know that you might have corresponding angles that should be equal. There could be co-interior angles that are supplementary, and there could be what? There could be alternate angles that are also equal. All right. So when you see parallel, without thinking, ladies and gentlemen, personality, you must think of corresponding, co-interior, and what? And an alternate. Okay. So in that grade 12 paper, once you see that they say, you could see a sketch that is messy and everything, but immediately when they say this line is parallel to this line, you must know for a fact that you will always find either one of these or a combination thereof. All right. Now, I think there's one thing that is also worth noting. NB, the inverse is the inverse of this theorem, is also true. Okay, what do I mean by the inverse of this theorem? Okay, remember the theorem says that if you have a parallel transversal lines, then corresponding angles are equal. Okay, so now the theorem, the converse of the theorem, or the inverse of the theorem, let me say the converse. The converse of the theorem will say that if you find corresponding angles on transversal lines, or that are made as a result of, or that are within transversal lines, therefore you must know that those transversal lines are what? Are parallel. So if you are told that if you do find somehow without using this, that okay, I've got corresponding angles that are equal, then for you can prove that the lines that are transversal in that situation, they are what? They are parallel. Also, if you can find a co-interior angles being supplementary, then you can also say that okay, the transversal lines involved there, they are what? They are parallel. Okay, so and then also you can say that if you have alternate angles that are equal, therefore the transversal lines are what? Are parallel. Now those theorems are very, very important, so be on a lookout for those kinds of theorems. Okay, so the converse of these theorems are true. Okay, yes. So if this is the case, you can say one of the three, either this or this or this. You don't have to say both of them. Okay, sometimes all of them will apply, or sometimes some of them, but it's either one or two or three. So by that way, what I mean is that if you've got corresponding angles that are equal, that is sufficient to say that the transversal lines that are involved in that kind of a situation, therefore those lines are parallel. All right, so let us then look at what? Let's look at the examples regarding this kind of thing, so that we can see how we go about to use these kinds of theorems. All right, okay, let's take the first one. Okay, before I even go to the first one, so I said the converse of these theorems are true, and then another important thing, NB, that I nearly forgot, is that these letters, I'm referring to these letters that are above, can be upside down. Guys, that is very important. So what do I mean by that? So see, for example, in this particular case, I've got this F being like this, and then I'm saying that this angle is equal to this angle, because they are corresponding angles. Okay, now that means if I have something like this, and then now transversal lines are like this, and then I can also say this angle is what? Is equal to this one. That is very important. Can you see this F is like this, and then this F is upside down. It can be tilted as well, or any shape. It does not matter. Okay, you can also have transversal line like this, and then you've got this one being parallel to this one, and then you've got this one being, it can be possible. Or here you can even have, you see this one is N, you can twist it and turn around, and then you can have something like this, and then you've got this angle being equal to its angle, because this line is parallel to this line. So these letters can be upside down. And ladies and gents, personalities, that is very important, because remember, in maths you don't get things in a way that you expect. Things can be in any way. So you must be ready on your side, that you must show your teachers that I did go through my work, I know my story, so whatever way you can bring these problems, I will be able to do what? I will be able to survive. Okay, do you understand? All right. Okay, let's continue then. Okay, let's take examples. Examples. Okay, now let's say we've got something like this. We've got this line, and then this line, and then this line, and then they say this is A, B, C, D, and then they say this is 40 degrees. This is 40 degrees, and then they say this is X, and then they say solve for X. Okay, so how do you do? And then they say this line is parallel to this line. Now I am teaching you how to use these theorems that you just spoke about to solve real life, not real life problems, these kind of problems. Okay, all right. So now I want you to follow me very closely and see what is it that I'm going to do. Okay, so I've got parallel lines, and then without thinking, when I see parallel lines, I know I will either have corresponding, I will have coincident, and I will have alternate angles. Okay, so it's fun. So I write my fun somewhere, and then I write it like this, and then I take this thing and I take these two angles, the one that I've been given and the one that I'm looking for. Okay, and then I would say to myself, okay, how can I combine? What is a way of combining what I've been given and what I've been looking for? So what you are given and what you have been looking for is in a U shape. So in our theorems, what is it that is on the U shape? Aha, there we go. It is co-interior angles. Okay, now what does that theorem say? It says that if you've got co-interior angles, if you've got lines, transversal lines being parallel, and then there's a U shape somewhere there because of those transversal lines that are parallel, therefore, what did they say? The co-interior angles are what? Are supplementary. Okay, so you will then say what? You will then say X plus 40 degrees is equal to 180 degrees. Okay, and then remember, this is geometry. So in geometry, when you do something, you must always show where are you taking it from. So where, Mr. Mataba, why are you saying this? Why are you saying this X plus 40 degrees is equal to 180 degrees? I'm saying it because corresponding angles are supplementary. I'm going to say sub for supplementary, and then I'm going to put comma, which means in mathematics, comma means since. So since AB is parallel to CD. Ladies and gentlemen, personality, this is very important. This statement is not valid without this reason. I'm saying X plus 40 degrees is equal to 180 degrees. Why? Because these are corresponding angles, and according to my rules, corresponding angles are supplementary. But how did I know that these are corresponding rules? I knew it because A, B, and then CD. AB is parallel to CD. If AB was not parallel to CD, then I can't use corresponding, I can't use co-interior, I can't use alternate. All right. So now I'm here. So from here, I know I can solve for X. I will then say equal to, and then I'll have X here, and then it will be 180 degrees minus 40 degrees. and then that will be nothing other than, so my x is going to be what? It's going to be 140 degrees. Okay, if I did not know these rules that deals with transversal lines which are parallel, then I wouldn't have been able to sort out this kind of a thing. All right, okay, so that is the first question. Okay, let's go to the second one. We are still solving for x. Let us put this one here as well. Let's put this one here, and then let's check another question. All right, so let's look at this other question. So we are still, okay, let me just put it nicely. We are still solving for x. Solve for x, and then what we have, we've got a line like this, and then we've got transversal lines, we've got transversal line, and then we've got 110 here, 1 centigrades, and then we've got x here, and then we have EF, we've got C, D, EF. Okay, again they are saying this line is parallel to this line. Okay, they are saying this line is parallel to this line. So without thinking, again, when they say parallel without thinking, what am I gonna do? I'm gonna say, okay, if there is parallel, then there must be either alternate or corresponding or coincident. One of or all of them should work. So I'm gonna look at which one am I going to use between those two. Okay, and then we must go and look at x that you have been given, and then we must relate it to, sorry, the x that we are looking for, and then we must relate it to the angle that we are given. Okay, so the angle that we are given in this particular case is 110 degrees. And then when you look at 110 degrees and then this x, you can see, can you see? Can you see? It is in the f, but the f that is upside down. You remember what I said here is that this f can be upside down. Do you remember? This is what I said here. These letters can be upside down. Okay, so now we are actually met with such case where this letter is upside down. So because of that, we'll then say, okay, now we're going to use corresponding angles. Now our theorem, what does our theorem say about corresponding angles? It says if you have parallel transversal lines, then corresponding angles are equal. So in this particular case, you're just going to say x is equal to 110 degrees. You don't even have to count anything, and the reason for that is corresponding. Hey, I just remembered something, guys. Here we made a mistake. It was not corresponding angles, it was co-interior. Okay, so this plus this is equal to 180 because co-interior angles are supplementary. I'm remembering it now when I'm raising, when I'm doing this one. Okay, all right, let's continue. Sorry for that mistake. So in this particular case, I can see very well this one and this one are corresponding angles, and then the rule says corresponding angles are equal. So x is equal to 110 degrees. Corresponding angles equal since what? Since EF is parallel to what? To CD. So our reason has two reasons inside them. It's very, very important. Okay, now the last one that we're going to deal with is this one. Okay, we are still solving for x, but now we've got this one, and then we've got this one, and then we've got this one. It's A, it's B, it's C, and D. Okay, this is number 3, this is number 2, this was number 1, the other one. Okay, and then in this particular case, you've got 110, 120 degrees, and then you've got your x here. Okay. Now, there is just one thing, guys, that I would like to emphasize here, and basically emphasize this for the whole of geometry. So, in geometry, you'll be given a messy situation, a situation that is a mess. And then you'll have to identify something that you are going to use at that particular point in time. And then you must forget others. And then when you have done that, then if you are going to the next one, then you use other things. I'm going to show you. So, for example, here, we are going to talk about what? Okay, again, we are going to look at two angles that we're dealing with. It's x and what? And it's x and this angle, which is 120 degrees. Now, when we are looking at these angles, now you can see somehow that it somehow forms, okay, what you are given is that this one is parallel to this one. Now, okay, you know you can either use this one or this one or this one, alternate or co-interior or corresponding angles, okay? But now, when you look at this one, you can see that's okay, you've got something which is a sort of Z. Now, let us just highlight it so that you can see. Can you see this one? You know, you've got this one, you've got this one, you've got this one. Can you see? It is a Z shape. Can you see that? Now, when something is a Z shape, what do you know about it? Okay, let me try and use another, because this one, can you see it? Yes, okay, I can see it. Okay, it's a Z shape, can you see? So, there is this angle and then this angle. Let me just put this one. Aha, can you see? Okay. So, if you don't have pens like mine, you sort of remove these lines in the eyes of your mind, and then you concentrate on this one, and you say, oh, this one is a Z shape, and then this line is parallel to this one. So because of that, it alternates angles. And what do they say about alternate angles? They are saying alternate angles are what? Alternate angles are equal. So because of that, you're going to say x is equal to 120 degrees. And then why are you saying that? Is because alternate angles equal since what? Since AB is parallel to CD. Okay? And then here you were dealing with corresponding angles. So corresponding in which form? It's either F. And then we said F either directly or flipped over. So in this case, you had something like this. You had this line, and then you had this one and this one. Can you see? Okay, you forget this one. Can you see this one? When you flip it over like this, it's F. Can you see? And then this one and this one, they are corresponding angles. And then the rule says what about it? It says they are equal. And then with the same breath here, you just look at this one. Can you see? Okay, so now you've got this line being parallel to this line, and then you've got a U shape. Okay, therefore you know that you are dealing with co-interior angles. And then what does the rule say about co-interior angles? They say co-interior angles are what? Are supplementary. Okay, so what am I saying to you, ladies and gentlemen? Personal assistants, Mr. Makaba, what are you saying to us? I'm simply saying that whenever you see parallel lines, and this is what I'm going to close with, whenever you see parallel lines, then you must think of corresponding, you must think of co-interior, and then it's corresponding, it's co-interior, and what? And alternate. angles. If you start thinking about that, you will actually start seeing the F shapes and then the U shapes and then the N or Z shape spinning around. And then also, please do not forget that these letters can be also upside down. Ladies and gentle personalities, if there's something that I missed, and if there's a mistake that I did, or if there is something that you need clarity on, there is a comment section below. Do not be afraid to ask or correct me. We are mathematics people. We make mistakes. We know very well that. And then, so if somebody corrects us, to us, correction is a gift. To us, feedback is a gift. It's not, you are not showing that you are more clever than us. No, you are just showing that there is a place where we made a mistake. And then when we see that there is a place where we made a mistake, we correct it. That is what mathematics people do. That is what scientists do. So ladies and gentlemen, personalities, thank you very much for tuning in. This is Mkonde Smakaba from Tembela Maths Club, a club that helps learners to understand mathematics. Enjoy your day and goodbye.